This tutorial explains how Scratch handles color spaces and how you can manage various color spaces within a single project. This tutorial presumes that you have a basic understanding of the concept of color spaces and are already familiar with the Scratch basics. If not, please have a look at the Scratch 101 video tutorial first. Let's start by going over the general concepts behind color management in Scratch. First, a Scratch project does not have a single working color space as some other software enforce. Scratch is completely color space agnostic. You do set a default color space for a project. This is, however, just used as initial value for new output nodes or media with missing metadata and can be changed at any time. You can mix shots in different color spaces in the same project just as easy as generating output in different color spaces from the same project. Scratch provides color management. All you need to set is the target color space for your output, and Scratch will take care of all the necessary transforms. Scratch supports all of the common color spaces used, such as sRGB, log, Rec 709, Ultra HD, XYZ, ACES, White Gamut, Scene Linear, P3 and Adobe RGB. And lastly, Scratch still offers the flexibility to provide your own custom transforms for any of those color spaces or non-supported color spaces anywhere in the pipeline. In fact, you can even turn off Scratch color management completely if you want to do it all by yourself. Now let's see how that works. As mentioned, you set a default project color space. If we open the project settings menu, you can see that the default for this project is set to Rec 709. Please remember that this is only a default setting used for the main output node of a new construct and when you load media without metadata. That default can be changed at any time. Let's enter the project. In Scratch, there are 3 levels where color spaces come into play. Each shot is flagged with a color space, as well as any output that you create. And the third place to manage color spaces is for your output devices, monitors and/or projectors. Let's look at the clip level first. We have a sample project with 4 different shots in our construct. If we look at the metadata stack of the shot by swiping to the right, we can see that each of those shots is flagged with a different color space. In most cases, Scratch will determine the color space from the metadata of the underlying source media file, but you can always change this manually if needed, as we will see later on in this tutorial. This first shot here is a ProRes file, labeled as RGB. The second one is Sony RAW debugged to Rec 709, hence is flagged as Rec 709, and so on. Please note that this color space flag in itself does not do anything to the pixel values of the image. It's just telling Scratch how to interpret the color of this image. This interpretation comes into play further downstream in the color pipeline when we want to display or render the image. Next to these shots, we are going to load another shot. In this case, we are going to load a TIFF sequence, which does not have any metadata of its own. Now, if you look at this section in the file browser, you can see the defaults that Scratch will use in case the shot itself does not have any metadata. These are the project defaults that we saw earlier. In this case, we know that the TIFF sequence is actually an XYZ shot, so we change the default here and load it. Next, let's look at our outputs. Here we have 2 created output nodes, and again, same as the clips, each of the output nodes is flagged with a color space. The first one set to P3, and the second one which is set to Rec 709. From here, we go to the player and open the Settings Monitor menu, where we set the properties for our output devices. Here you can see that you can flag each of the output devices with its own color space. In this case, I'm using a regular computer monitor for my primary display and flagged it Rec 709. And I'm using a projector on my SDI out, which I'm feeding P3. Now if you look closer to the menu, you see that next to the color space setting, each of the devices also has an Apply Color Space option. In fact, if you recall the color space setting from the output nodes, that also had an Apply option, which has the same function for rendering. With these buttons you control the Scratch color management. By default, the buttons are enabled, and what they do is that Scratch will compare the color space of the output node or output device with that of its input, a clip or another output node. And if that color space is different, Scratch will automatically apply a transform. Let me show you what I'm talking about. As you can see, on the primary display you can turn color management on and off for the dual view separately. To show you the effect of Scratch color management, I'm going to turn it off for dual view. I now hit the D button on my keyboard to go into dual view mode, so we can see side by side how our clips look with and without color management applied. Let's switch to the config menu inside the matrix. We can see that the current shot is flagged as being sRGB. As you remember, our primary display was flagged as Rec 709. Now sRGB and Rec 709 are very similar color spaces. Yet, if you look at the dual view, you can see a difference. The left view, for which we applied color management, looks different from the right view, for which we disabled color management. Let me quickly switch into over mode, so we can better see the difference. Back to dual view. We can even show this better if we change the color space flag of the current shot. Let's, as an example, change it to white gumwood. Now, as said earlier, the fact that you mark a shot with a certain color space does not mean a transform takes place automatically. This is important to understand. Labeling a shot as white gumwood does not alter the pixel values. As you can see, the right view still shows the same image. Changing the color space from sRGB to white gumwood did not change it. The left view did change, however. Because we enabled color management for that view, Scratch automatically performs a white gumwood to Rec 709 conversion just before it displays the image. Now of course, the image looks horrible. Just setting a wrong color space will also cause Scratch to do the wrong conversion. We only did this to show you the effect. Let's change this shot back to its actual color space and move on to the next shot. This shot is a Sony RAW shot, and we set it to debuyer to Rec 709. Looking at the config menu, you can see it's also flagged to Rec 709. This time we see no difference between the left and the right view. Because the color spaces of the shot and the monitor are both Rec 709, no transform is required by Scratch color management. Back to the shot menu. If we now change the debuyer setting of the shot to create an ACES image, we do see the right view change considerably. First thing to notice is that when we change the debuyer setting to ACES, Scratch automatically also switched the color space flag to ACES, as now the result of the debuyer is an image in the ACES color space. The left view did change as one would expect when switching to the wider ACES gamut. Simply because ACES delivers much more color information than Rec 709. For displaying this correct, Scratch color management is now performing an ACES to Rec 709 transform just before it puts the image on the left view. Again, for the right view, we disabled color management, and Scratch will now pass on the ACES image that is coming from the debuyer one-on-one to the display. As you can see, our monitor is not very well suited to display ACES. What is very important to understand is that the transform we are seeing are performed on the image just before it is displayed. It has no effect when we render out the image to file. remember that each output node has its own color management setting. Let's go back to the output module. As we showed earlier, each output node also has its own color space set and has its own apply button, which works completely independently from our output device settings. When we render out this node, Scratch will automatically apply a transform on each shot on the timeline that has a different color space from that of the output node. So in this case, Scratch will render EXR files and convert each shot on the timeline to the P3 color space. Now if we were to view the output node in the player again, by pressing the play button, Scratch color management would kick in again. It notices the shot being in P3, but also our main display is set to Rec 709, and so Scratch does the proper transform before displaying it. For our projector view, no additional transform is needed, as that already expects P3. That is it. This is in a nutshell how Scratch manages color spaces and how you can easily combine multiple color spaces in a single project. Thanks for watching. Bye bye.